we discussed the definition of relation I discussed, and also I discussed types of relations. So in that, my dear students, I discussed what is mean by reflexive, what is mean by symmetric, and what is mean by transitive relations. That all we discussed in the previous videos. Today's class, my dear students, I am going to discuss, or I am going to solve the questions like this, 1 mark questions. So these are the questions in your annual examinations. They may ask, my dear students, for 1 mark. So before solving these questions, my dear students, please remember, already I wrote on the board all the questions. I given here it is some space. There I will solve the questions for answers. I'll solve here answers. So why I wrote means, my dear students, if I while doing the video, if I write means it will take lots of time. So therefore what I did, my dear students, just I wrote the questions on the board. So now I'll solve. So before solving that, my dear students, we should know some concept. That is what we discussed. Revision I'll do, my dear students. So in the last class, what I discussed, my dear students, a relation R. Here it is a relation R on a set A is said to be reflexive. A relation R on a set A is said to be reflexive if A comma A belongs to R for every A belongs to the set A. A relation, my dear students, a relation R on a set A is said to be reflexive if A comma A belongs to R for every A belongs to A. It means, my dear students, if you have any one set A, if every element of A is related to itself, then such a relation we can call it as reflexive. This I discussed. Clear? And next, my dear students, second one is, here it is symmetric. So my dear students, symmetric means what? If A comma B belongs to R, if any one ordered pair is there in the relation R, means the reverse of the after interchanging these places elements, that order pair also contained in the relation, then we can say that such type of relation we can say that symmetric relation. If A comma B belongs to R and B comma A belongs to R, or else you can take it as, my dear students, if A comma B belongs to R, this implies that, this must implies that, if it implies B comma A belongs to R, then we can say that relation R is a symmetric relation. If A comma B belongs to R, this implies that B comma A belongs to R. It means if A comma B is any one general, here I am denoting, here it is general I am discussing. So therefore I am taking the elements A comma B. If any one order pair is there, A comma B in the relation R, means you should interchange the places. So B comma A, if after interchanging this, whatever you will get the order pair, if that order pair is also contained in, if that is also in the relation R, means such a relation we can call it as symmetric relation. And this A and B must be belongs to, my dear students, where A, B belongs to the set A. That should be in the set A. And next, my dear students, the third one we discussed, that is transitive. So transitive means what, my dear students? Any relation R on a set A is said to be transitive if, my dear students, this is the case, if A comma B belongs to R and another one case is B comma C belongs to R. This must implies that if there are two ordered pairs A comma B and B comma C, then this must implies that we should check whether this A comma C is there or not. We should check. If A comma C belongs to R, then such a relation we can call it as transitive relation. So this is, my dear students, these are the three important relations I discussed in the previous video. And now my dear students, these three, if any relation R is said to be equivalence relation. Equivalence relation means what? If these three relations are satisfying, then such a relation R we can call it as the equivalence relation. This is all my dear students. Here it is basic, we should know to solve these questions. Clear? So my dear students, please remember all these results. These are very important. Now we'll move to the questions, my dear students. I hope you understood. Still, if you have any doubts, you can comment me. I'll reply for that. And please make sure that while watching my videos, you should be known of the previous videos. You should be seen by the previous videos. Then only you can come to know this, whatever I'm explaining now, that you will come to know. Because all this concept I discussed in the previous video. So my dear students, it will be helpful to you if you watched my previous videos. Then only this class will be helpful to you. Clear? If you are new one means you are watching first time means please go through my previous videos. Clear? So now my dear students, come to the questions. So first question I given to you, here it is. Give an example of a relation which is reflexive but neither symmetric nor transitive. My dear students, we should give an example. We should create ourselves a set, a relation. We should give a relation in such a way that we should take the example, or we should give the example of a relation which is reflexive. It must be reflexive but neither symmetric nor transitive. Such a example we should give. For that, my dear students, always while discussing the relation, while defining the relation, I should know the set here. Clear? So for that reason, I am taking, my dear students, let us take one set. Here it is. Let A is equals to 1, 2, 3. This is the one set I considered, my dear students. Please remember, whenever you are defining the relation or whenever you are giving the examples, you should know what is the set where you are defining the relation. Clear? For that reason I am taking one, here it is, set A I took, here it is. In that we have the elements 1, 2, 3. Now my dear students, I'll take the relation. So I am giving the example, here it is. So that I am naming it as R. So we should take the relation, we should give the example in which give an example of a relation which is reflexive. Reflexive means what, my dear students? Already I told to you that reflexive means in a set A, whatever elements we have, that element must be belongs to the itself. Such a relation, such a order pair must be there. Such a relation we can call it as reflexive. So here it is. What I will do, my dear students? Here it is. In a set, how many elements are there? 3 elements are there. So every element, 1 is there. It should be related to itself. 2 is there. 2 should be related to itself. 3 is there. 3 should be related to itself. Now this relation we can call it as reflexive. Reflexive means what? Every element of A should related to itself. So therefore I wrote here it is 1, 1, 2, 2, 3, 3, like this I wrote. So my dear students, this is now this relation we can say that this is now it is a reflexive. But my dear students, it's not our task. What is our question given to? What we are giving example? We are giving example which is reflexive but neither symmetric nor transitive. My dear students, now it is reflexive because every element of A is related to itself. Now whatever I write here, so here it is, whatever I wrote, this relation is reflexive. Next, what should we check? Whether it should not be neither symmetric nor transitive. So therefore I'll check whether it is symmetric or not. We should check. So we should take care of, it should not be symmetric, it should not be transitive. My dear students, here it is 1, 1. What is the, here it is, you can take it as reverse, I'll take. So 1, 1 means if you take the ulta, that will be 1, 1. Again it's there. It means it is symmetric. 2, 2, ulta is 2, 2. Again it is there. 3, 3. If you interchange the places, again it is 3, 3. It means here it is, now it is symmetric. but actually what should I write? I should write which is not a symmetric. So for that reason, what I'll do, my dear students, I'll take one such a order pair. Here it is, that is 1, 3. Any element you can take. Now I am taking, here it is 1, 3. My dear students, what happens here it is, now I'll take, here it is 1, 3. If I take 1, 3, what happening here it is 1 to 1, 3, which means here it is 3, there. If I write means, then that will become symmetric. Now it is not a symmetric, because 1, 3 I wrote. The reverse ulta process, ulta if I take means 3, 1. 3, 1 I am not writing. 3, 1 I am not writing, because if I write means that will become symmetric. But my aim is this should not be symmetric. So one order pair I took 1, 3. So if you take reverse of this means, what happens here it is, that will become, my dear students, here it is symmetric. So therefore I didn't took. And now, my dear students, if you take, here it is 1, 1. Now I'll check transitive. So transitive, for transitive, my dear students, 1, 1 is there, 1, 3 is there. It means here it is 1, here it is 1, here it is 1, and here it is 1. So 1, 1 is there. If what is transitive? If A, B is there, B, C is there, then A, C is there or not, we should check. It means 1, 1 is there, 1, 3 is there. Now 1, 3. Here it is 1, 1, 1, 3, and this in this order pair first element, in this order pair second element, 1, 3. Is it there? Yes, it's here. 1, 3 is there. So therefore, what happens? It is becoming a transitive relation. Again, I should cancel that term. I am not taking this 1, 3. If I take 1, 3, what happens? This will become transitive. But my aim is it should not be transitive. So for that reason, what I'll do, my dear students, or else I'll take, here it is, I'll take it as, here it is 3, 2. If I take 3, 2, what happens, my dear students? Again, here it is 3, 2. Again it will come. So therefore, I'll take, or else I'll take, here it is 3, 2. If I take 3, 2, my dear students, again you can check 3, here it is 3. It means 3, 2. Again 3, 2 is there. Now it is becoming, here it is, again it's becoming transitive. So for that reason, what I'll do, my dear students, I'll take another one order pair, that is 2, 1. So 2, 1. If I take another one order pair means, now check, my dear students, here it is 1, 1, 2, 2, 3, 3. It is reflexive. It is not symmetric. Why it is not symmetric? 3, 2 is there. The ulta here it is. If we take interchange the places, 2, 3. Whether 2, 3 is there in this relation? In this relation, I didn't wrote 2, 3. It means this is not a symmetric. Clear? Am I clear? And next, my students, whether it is transitive, I'll check. Whether it is transitive, yes, here it is. Check the order pairs. 3, 3, 3, 2. It means 3, 2. Again 3, 2 is there. Now 3, 2, 2, 1. So 3, 1 is there. 3, 1 is not there. So therefore it is not a transitive, not a symmetric, but it is a reflexive. Like this we should write, my dear students. Clear? And now similarly we should write the next I am going to discuss the next second question. Here it is. What they given to you? Here it is, give an example of a relation which is symmetric but neither reflexive nor transitive. Again I am taking the same set, my dear students. Let A is equals to 1, 2, 3. And now I will take the one example. What is that? That you should take that relation which is, here it is, neither reflexive nor transitive. Neither reflexive means this should not contain 1, 1, 2, 2, 3, 3. Then it will, we can call it as the relation as reflexive. So now not reflexive. If the 1, 1, 2, 2, 3, 3 is any one among that not there in this relation, means such a relation we can call it as not reflexive. So now, but I am interested to write the example of which is a symmetric. So my dear, symmetric means what I will take, my dear students, 1, 1 I will take. Now it is, my dear students, or else take, here it is 1, 2 and 2, 1. My dear students, please remember, whether it is reflexive, it is not a reflexive, because 1 comma 1 is not there, 2 comma 2 is not there, 3 comma 3 is not there. It means every element of A is not related to itself. So therefore this is not a reflexive. Now check whether it is transitive. Transitive means what I told to you, my dear students. We should have the two ordered pairs. We should have the two ordered pairs, that too in this form. A comma B belongs to R, B comma C belongs to R. If these two ordered pairs there means, next we should check that whether in this order pair first element, in this order pair second element is there or not. We should check. And now my dear students, if you can see 1 comma 2 is there, 2 comma 1 is there. Now whether this element and this element, whether 1 comma 1 is there, and I am not writing 1 comma 1 because if I write means that will become transitive, but I should write the example for the not transitive. So therefore this is example for the, here it is transitive, here it is not a transitive, not reflexive, but it is a symmetric. Why it is symmetric? 1 comma 2, if you take reverse of this means ulta, if you take 2 comma 1, it means here it is, this is the relation R, which is example for the symmetric but neither reflexive nor transitive. Like this you should write, my dear students. These are the very important in your annual examinations. They will give the questions like this. For that reason, my dear students, very important here it is. So to understand this, we should know the knowledge of this reflexive, what is meant by reflexive, what is meant by symmetric, and what is meant by transitive. Next we will move to the third question, my dear students. So what is in third questions, my dear students? Here it is, give an example of a relation which is transitive but neither reflexive nor symmetric. We should take such example. Again I will take the same set, my dear students. Let A is equals to 1, 2, 3. Now I will define the relation R in such a way that should not be reflexive and not a symmetric, my dear students. So it means but that should be a transitive. So I will take one order pair 1 comma 2. And next, my dear students, I will take 2 comma, here it is 3, and now I will take, here it is 1 comma 3. My dear students, please remember this is example for the relation which is transitive but neither reflexive nor symmetric. I'll discuss why it is so. My dear students, to say reflexive, what is the condition? 1 comma 1 must be here, 2 comma 2 must be here, 3 comma 3 must be here. If these all three ordered pairs are there means then we can say that reflexive. But here it is, now it does not contains 1 comma 1, 2 comma 2, 3 comma 3. So therefore it is not a reflexive. Next, to say any relation symmetric, what should we know? The ulta, we should ulta, it means if you interchange any order pair, if you interchange the elements, that such order pair must be there. 1 comma 2 ulta 2 comma 1 is there? No. 2 comma 3 ulta 3 comma 2 is there? No. 1 comma 3 ulta 3 comma 1 is there? No. So therefore it is not a symmetric, not a reflexive. But my dear students, to say the transitive, what is the condition we have? To say the transitive, A comma B is there and B comma C is there means then we should check whether A comma C is there or not. That we should check. So my dear students, come here. So let's discuss. Here it is, 1 comma 2 is there, 2 comma 3 is there. It means here this order pair and this order pair are equal. If this order pair and this order pair are equal means next our job is whether this element and this element is related to this element and this element or not. We should check. Yes, 1 comma 3 is related, it means it's here. So therefore it is a relation, it is here it is transitive but neither reflexive nor symmetric. Like this we should write the examples, my dear students. Very important it is. Clear? I hope you understood. Still if you have any doubts you can comment me, my dear students. I'll reply for that. And next we will move to the next question, my dear students. So what is here it is, my dear students, give an example of a relation which is reflexive and symmetric but not transitive. My dear students, here it is. Again what I'll do, let us consider. Let A is equals to 1, 2, 3. These are the three sets, three elements I'll take, my dear students. So in this set what I'll do, my dear students, I'll define one relation. So how to define a relation, my dear students? Here it is, give an example of a relation which is reflexive. Reflexive means what, my dear students? Every element should be related to itself. So therefore 1 comma 1, 2 comma 2, 3, 3. So now it is reflexive. And now my students, what they are telling? And symmetric, it must be symmetric. Symmetric means ulta must be there. 1, 1. If you interchange the places means again it is 1, 1. 2, 2. If you interchange the places means again it is 2, 2. 3, 3. If you interchange the places means 3, 3. So it is reflexive and symmetric, but it should not be transitive, my dear students. So it should not be transitive means only I write this much means, my dear students, it is a transitive. Why it is transitive? Transitive means what? Here it is, if A, B belongs to R and B, C belongs to R, this must implies that A, C must be belongs to in the relation R. But here what happening, my students? There is no any ordered pairs in the form of A, B, B, C. In this form means what, my students? There is no any two order pairs which have the same element. Here it is in the order pair second element, and here it is in this order pair first element. There is no any such elements are there. Such order pairs are there. These three are different. So therefore here it is no case of here it is A, B as well as B, C. If these two type order pairs are not there means we won't check this one. So trivially we can call it as the transitive relation. So therefore my dear students, here it is, if you write this much means it will become transitive. But what should we write? That should not be transitive. For that reason, my dear students, I'll take some more elements. I am taking here it is 1, 2, 2, 3. I'll take, my dear students. If you take 1, 2 and 2, 3, my dear students, check here it is 1, 2, 2, 3. It means here it is 1, 3 must be there. So here is there 1, 3? 1, 3 is not there. So therefore it is not a transitive. But my dear students, we should observe that whether these two here it is, whether it is a already it is reflexive, whether it is symmetric or not, we should check. To say symmetric, my dear students, 1, 2, if you consider this order pair, the ulta, if you interchange the places means 2, 1. 2, 1 is not there. So therefore I'll write this here it is 2, 1. And next 2, 3 is there. I'll write reverse of this, that is 3, 2. Now my dear students, you can observe this is reflexive. Here it is 1, 1, 2, 2, 3, 3. Every element of this here it is in the given set, every element is related to itself. So therefore 1, 1, 2, 2, 3, 3 is there. Hence it is reflexive. And next symmetric. So already up to here I discussed 1, 1 ulta means if you interchange the first element and second element, again that is 1, 1. 2, 2. If you interchange means 2, 2. If you interchange 3, 3 means again it is 3, 3. So all these three elements, three order pairs are symmetric. And now my dear students, I'll check these elements. 1, 2. Reverse of this is 2, 1 is there. 2, 3. Reverse of this is 3, 2 is there. So therefore this relation is reflexive as well as symmetric, my dear students. But it is not transitive. Why it is not transitive? 1, 2 is there. 2, 3 is there. It means 1, 3 must be there in this relation to say transitive, but it is 1, 3 is not there, so therefore it is not a transitive. So therefore this is example for the given question. Like this we should write, my dear students. So this type of questions 1 mark usually they'll ask in your annual examinations, or sometimes you may this type of questions may appear in your competitive exams like CET and JEE. In that also they can ask, my dear students. I hope you understood. Still, if you have any doubts, you can comment me. I'll reply for that, and we'll continue in the next video. Thank you.